I'm here now with Christophe Fergeau, who will talk about vfkit. And before we start the session, I just want to let you know that you can ask questions in the Q&A section, and we will get to it at the end of the session after the presentation. So with that being said, Christophe, floor is yours.
Thank you, Lenka. Hi, everyone. Thank you for attending my presentation about vfkit, which is a macOS hypervisor written using the Virtualization framework. So first, a little bit about myself. So my name is Christophe Fergeau. I'm a senior software engineer at Red Hat, and I'm working in the CRC team. CRC is also known as OpenShift Local. I will explain a little bit later what this is. This is about it. I used to be working in the virtualization team on a protocol to remotely show the VM displays. So today, first, the talk is named vfkit, a macOS hypervisor. So we are going first to see why we need a hypervisor to run containers. It's container plumbing after all, so it's a bit weird to talk about hypervisors. Then I will present what Apple's virtualization framework is. And finally, I will present vfkit, which is the tool I wanted to talk about today. So a little bit of background to start. Why do we need hypervisor to run containers? So when I say hypervisor, I mean some tool to start a virtual machine and to run a virtual machine. Because if you take a container, it's an image that you can download, and inside this image you have some Linux binaries that you can run. And if you are doing this on a Linux machine, on a Linux server, or on a Linux distro, all is fine. You have this binary inside your container image. It's fairly easy to run them, so you have no issues. But basically, more and more people, they want to be able to develop and to run containers on macOS and on Windows. And in this case, it's not as easy as on Linux to run the containers, because I will focus on macOS for this talk because I'm talking about a macOS hypervisor. So if you are on macOS, you download an image, and then you have this image with the Linux binaries. macOS don't really have a way of running the binaries natively. So you are a little bit stuck. So what's the container applications are doing? So for example, Podman, is that they are using a virtual machine on macOS and on Windows to actually run the containers. Docker is also doing this. And so, for example, if I want to run a container using Podman on macOS, Podman comes with a command which is called podman-machine. And so I would use this to create a Linux virtual machine on my macOS laptop. And then once I have the virtual machine, I can just run the containers. And what's going to happen is that Podman is going to connect to the virtual machine and then run the container, the Linux container inside the virtual machine. This is very transparent. It sounds complicated when I explain it, but all you have to do is that you run podman-machine init --now. If you look at the logs that it's printing, there will be one line saying waiting for VM. So it created a virtual machine for you, and then it's waiting for the virtual machine to be ready. And once you have the virtual machine, you don't really notice it's running. On the command line on macOS, you can just run podman run hello world, and it's going to connect to that virtual machine and run the container inside the virtual machine. And then you will see the result on your macOS terminal, just as if you had run everything inside on macOS and not through a virtual machine. So it's so transparent, it seems magic, but it's not. You need to run a Linux binary. Well, you start a Linux virtual machine and then you do everything inside. And so I'm getting to CRC-OpenShift Local, which is the tool I'm working on. So a few words about it first. So it is a way of running an OpenShift cluster locally on a Linux machine, but also it can be run on a macOS or Windows machine. And so this will run an OpenShift cluster on your machine. So OpenShift is the Red Hat Kubernetes version. And so why would we want to do that? It's mostly useful for developers I mean, if you, I don't know, you want to develop on an OpenShift application, or even you want to experiment with the cluster, maybe you want to be an administrator on that cluster. If you want to do some like real crazy test, maybe you might be breaking the cluster or some stuff on the cluster. So it's convenient to have this local cluster that you own, because you can do anything that you want on it. And even if it's broken or anything, you can easily recreate it and experiment some more. So yeah, this was the initial goal of CRC. And so to achieve that on macOS or Windows, it's exactly the same scenario as what I described for podman-machine. So you run CRC start, and it's going to create a virtual machine. And then inside that virtual machine, it's going to run an OpenShift cluster. Because, yeah, and a Kubernetes cluster, it's a bunch of Linux binaries that you're going to run, which are going then to run containers. So yeah, macOS and Windows, we do not really have a choice. It's the same. We run a virtual machine, and then we do everything inside. And since we had this way of running a Kubernetes runtime inside a virtual machine on macOS and Windows, we decided, okay, we also could try to have some lighter weight way of running containers. And so we also have a way of only starting a podman runtime, and we have something similar to podman-machine. So you type CRC start in order to start the virtual machine with the podman runtime in it. And then on your Mac machine, you can run podman run some cluster image, and it's going to connect to the virtual machine, download the container image, and then run it transparently, even if you're on macOS. So you can experiment with with container development and with running containers all from your macOS machine without really noticing it really is a Linux container. So so far I've said, okay, you can already use containers running in virtual machines on macOS. You can do this with podman. You can do this with CRC. But still, I'm here to talk about a new hypervisor, which is named vfkit. It's something we developed in the CRC team because we needed that. But yeah, why? So for some context on that, so in CRC, what we needed was something which was free software. Yeah, we are at Red Hat, so we don't really want some proprietary stuff. And for our ease of use, it's something we wanted something we could control for the command line, and which was quite lightweight. That is, which did not come with a management application with lots of things, graphical interface, and everything. We wanted something as small as possible. So a few years back, we were using hypervisor, which is the same hypervisor that Docker is using on macOS. But yeah, the problem with it is that it's using some low-level x86 APIs in order to like create the virtual machine, handle it, and do everything that is needed. And yeah, a few years ago is when Apple announced that they would be switching from Intel-based CPUs to their own CPUs, what I'm going to call Apple Silicon CPUs, or just the M1. So they are ARM-based CPUs, so hypervisor was not going to work on this. It would need to be ported or to have like both x86 and ARM. And it did not look like it would happen. In my team, we knew we would not be able to do it. And actually, I'm not sure it's been ported to ARM at all. So yeah, we knew we were in some kind of dead end with hypervisor for use with CRC. And so we needed something else on macOS if we wanted to be able to support the new Apple Silicon CPUs. So yeah, no support for Apple Silicon CPUs, so we could no longer use hypervisor. So the next, not so obvious choice, but the next thing we looked at was QEMU, because yeah, basically it already had a macOS port. It's available in Brew. It's like well supported. It has tons of developers. So yeah, we were like at first, yeah, it would be nice if we could use QEMU, but it was also not a great fit for our team because yeah, so CRC is something that Red Hat is shipping to customers. we could not really tell our customers, oh yeah, it's no problem. So it uses QEMU. So you go to brew, you run brew install QEMU, and then you take our binaries, and then it's going to work. There was some expectation that everything that we ship would be built internally on Red Hat infrastructure before being shipped to customers. So we would have to rebuild QEMU anyway. So we have some great teams at Red Hat doing some QEMU work. But yeah, they're obviously like focused on Linux QEMU builds and Linux QEMU support. And yeah, there was no one who would provide macOS binaries inside Red Hat. So if we wanted to be able to use QEMU with our stuff, we would have to build it ourselves. And well, it's a very complicated beast, QEMU, like it's 2 million lines of C code. So yeah, we could build it for macOS. But then it's a huge code base, so there would be security issues at some point, some CVs, so we would have to rebuild it. And we really were worried that, yeah, it would take quite some time to make the QEMU builds. If we had some bugs related to the virtual machine emulation on macOS, it would also be a problem. So yeah, QEMU, yeah, we could use it, but it would be quite some work. And we preferred, okay, can we avoid that? So this is why we were looking if there were some alternatives to QEMU that we could use to have like some virtual machines on macOS for CRC. So yeah, we looked a bit, but we could not really find some great tools for that. But this was at the time that Apple was starting to ship their virtualization framework. So now we're going to see in a little bit more details what the Apple Virtualization Framework is. So it's something which was released with macOS 11, so a few years ago. And it's a high-level API to create Linux and macOS virtual machines. And yeah, I really want to insist on the high-level part of this, because yeah, this means that it's really handling a lot of the complexity of creating virtual machines and running them. If you want to create a virtual machine using the virtualization framework, it's maybe 100 lines of code or something like that. It's not like millions of lines of code like QEMU. It really can be done with not many lines of code. So it's something provided by Apple, so you have to use Swift or Objective-C in order to use it. And yeah, just an API, just a framework. Yeah, I think what they call framework is a library, shared library on Linux. It's not, they don't provide any application using their framework. So you don't have any command line tool, any user interface tool to manage the virtual machines. It's really just the framework. So if you need it, okay, you have some API to create a virtual machine and run it. So yeah, you have this. So what does it provide? So yeah, it tries to provide everything that you need for a virtual machine, but yeah, the minimum set of API possible to do that, because in QEMU you have multiple devices for networking, multiple devices for storage and everything. The Apple Virtualization Framework, from that perspective, is fairly minimal. It only supports Virtio, which is like a way of having virtual devices inside the virtual machines, but they really rely on the running in a virtual machine and having a host operating system to do some of the complicated work. And so the devices themselves inside the VM are fairly lightweight. So yeah, it's easier to use, but yeah, it does not map to real hardware. So they only support that. But yeah, they have like Virtio Net for network communication, Virtio Block for handling the disk, and so having some disk image where you can install stuff, run stuff from, and so on. And then it has some additional devices like Virtio Serial to get a serial console to your virtual machine if you don't have a graphical interface. Virtio RNG for random number generation, Virtio Balloon to dynamically handle the memory. And they also provide support for graphical VMs. Personally, I never tried it, but yeah, they have like video devices, sound devices, keyboard pointing devices. So if you want a graphical Linux or macOS guest in a virtual machine, you also have a way with the virtualization framework of getting this. And then, yes, some additional API, which is really useful for our needs. There's VataUFS for file sharing between the host and the guest. So yeah, it's a dedicated device, and it's quite efficient. So it's very nice to have this instead of having to go through like networking and complicated stuff to be able to share files between the host and the guest. And you also have VataU vSoc. If you need a connection from the host to the guest, I don't know, if you have a daemon running inside the virtual machine and you want to communicate with it, you can use this VataU vSoc, which is really dedicated to communication between the host and the virtual machine using POSIX sockets, and it removes the need for a networking stack and everything, so it's much simpler to use that. So it's nice that they have this in the virtualization framework. So yeah, after this quick overview, so does it have what we need to run containers? Well, they have UEFI support, so they can run modern Linux distributions. So if you have a modern Linux distribution, well, you can have any container engine that you want. You can have podman in it, you could have Docker or whatever you want. So yeah, from that perspective, it's going to be able to run a virtual machine which is good enough to run containers inside. Well, it has networking support. It's kind of obvious that you would have that for something creating virtual machines, but yeah, it's there. Yeah, file sharing is particularly important for the container use case because, you know, if you want to run podman run -v and some directory on the host to share it with the container, you need a way of sharing files from the host to the VM so that the VM can share that with the containers. And so it's good that we have VataUFS to do this. Yeah, and to come back to the problems that we, the CRC team, had with QEMU, yeah, it's also like a big framework. So it's maintained by Apple. We don't have to build it. We don't have to ship it. It's already available on the macOS machines. So from our perspective, it was very nice because we moved from having some huge code base to maintain to having something fairly small using this framework if we were to use it to have a hypervisor. There's some minuses. So it's just an API, just a library. So we need to write something to use it. And yeah, one other drawback, yeah, for my team, once again, is that it's written in Objective-C or Swift. And yeah, basically, I don't know Objective-C or Swift, and not many people in my team were familiar with it. So yeah, this was something which was kind of annoying with that framework, but it was still good enough that we had it in our mind and we kept thinking about it. And yeah, one more thing. Yeah, Apple talks have to have something like that. Yeah, Rosetta support. So Rosetta is something that Apple added when they moved from Intel machines to Apple Silicon machines, because they wanted a way to be able on macOS to run x86 binaries, even if you are using an M1 CPU. This is quite nice, working very well. So you can use like most of the application written for Intel hardware on a Mac M1. And yeah, it's quite efficient, so it's good to have. And actually, they added support for Rosetta also in the virtualization framework, so that you can have a Linux virtual machine, an ARM-based virtual machine running on your MacBook. And inside that virtual machine, you can use Rosetta in order to start an x86 binary. And so what this means is that if you are on a M1 machine, you have your ARM Linux virtual machine to run containers. You're not limited to ARM containers. You could also run x86 container images on your M1 machine. So yeah, this is definitely some very nice feature to have. With QEMU, you can have something similar, which is a QEMU user static. So it's good to have feature parity on that side. And so after this overview of the Apple virtualization framework, we're getting to vfkit. So yeah, at this point, we know that the Apple virtualization framework looked nice for what we wanted to do. But yeah, we had to write some tool and to write that in a language we were not familiar with. And this is when searching around, we found this project, which is codehex/vz. It's written by someone named Keikohex Kamikawa. And it provides Go bindings for the Apple Virtualization Framework. And basically, this was exactly what we needed. In my team, CRC is written in Go. Kubernetes and OpenShift, they are mostly Go code. Podman is also written in Go. So yeah, having some Go bindings for this framework was just a great fit for what we wanted. And yeah, this is using MIT licensing. So it was open source as we needed at first. And it follows very closely the new APIs added in macOS 12 and 13, which was also important because the virtualization framework as it was in macOS 11 did not have enough features for what we needed. So we really needed some of the new APIs in macOS 12, which is the file sharing, and macOS 13. So yeah, it makes it easier to start virtual machines. So it's good to have. And so, yeah, once we found that, we decided to write some command line tool using these bindings in Go to manage the VM. So you might wonder, okay, you have Go bindings, so why not use directly these bindings inside your application? And that's it. You don't really need some external tool for that. One thing I did not say about the virtualization framework, right, I said that it's a framework and does not provide a command line tool. But also, the VM that you create and start is going to die when your process ends. So if you have a short-lived process and start a VM in it, the VM is also going to be short-lived. So this is why you need some other process which is going to run for a long time, because you want it to run as long as you need your VM to be around. And so doing this in a separate command line tool was a good way of having something alive as long as the VM is alive. And so this is why we decided to go with this separate tool. So it's written in Go. It's a command line interface to the bindings, which are using the Apple Virtualization Framework. So yeah, as you can see, in a way, it's simple. The command line is long, but yeah, it's telling, okay, start a VM with 2 CPUs, with 2 gigs of RAM. It tells it how to start it. It tells it to have a serial console, file sharing, to use disk image for it, to have networking. So you can specify the MAC address if you want to always get the same IP from DHCP. So yeah, it's doing a lot of stuff. So all the devices that I presented before, well, you can configure them and use them in your VM. If you don't want file sharing, you don't add the line for file sharing, for example. And once you do this, the VM is going to start. And when you don't need it, you no longer need it, you can press Control-C, for example, and the VM is going to end. So since it's written in Go and our tool are written in Go, it also provides an API to make it easier to configure the VM. So you create the VM configuration in Go, and once you're done, you just ask for the command line to start the VM. And so you don't need to bother with to build yourself the very long command line I showed before. So what's next in vfkit? So at this point, vfkit is used by CRC. We've been using it for quite a while, actually, maybe 1 year, maybe more. I did not check. And we did not have any significant issues with it. And now, yeah, I would like to also see what we could do to use it in podman-machine. At the moment, podman-machine is using QEMU. It would be a nice alternative to have vfkit support there. The main missing piece at this point is ignition support. Ignition is a way of configuring the VM the first time you start it. And to pass the configuration from the host to the guest, podman-machine is using some QEMU-specific API. Ignition expects that, so I need to figure a different way of doing this with the vfkit. So yeah, something I haven't looked at yet, but would be nice to have. Rosetta support, it's present in the virtualization framework. It's present in the bindings I'm using, but it's not added yet to CRC, to vfkit. Yeah, and better integration with user-mod networking stacks. Yeah, user-mod networking stacks are kind of required for CRC use case because otherwise we get into issues with corporate environments, with VPNs, and yeah, redirecting everything to the corporate network. So these stacks are a way of getting around that. Yeah, and I want to improve a little bit the integration to have something very easy to use with the vfkit. Yeah, this is it for this presentation. So if there are any questions, I'm happy to answer them. Thank you for listening.
Thank you so much, Christophe. You ended right on the time, and I'm checking the chat. I can see Akihiro, maybe off-topic question for the vfkit session. But how do you compare CRC with Podman Desktop OpenShift extension?
Yeah, I see that Praveen has already answered. I'm reading his answer actually.
Okay.
The Purement extension, OpenShift extension, Podman Desktop, it can connect remotely with the cluster or the local one. CRC really is creating a local cluster that you own and you can do whatever you want with it. We are currently working on an extension to make that easier to use.
Okay. And we have one more question from John. Does future support for Rosetta mean that vfkit doesn't work on M1 Mac?
No, it works on M1 Mac. What this means is that we don't use Rosetta to run x86 containers on the M1 Macs. We install QEMU user static actually in our virtual machine images, which is doing about the same as Rosetta. If we have a native solution provided by Apple, we could as well use that. We just need to add it at some point.
Okay. Thank you. And we have one more question, and that would be the final one from Dan. Why is support of this easier than QEMU? What happens when there is a CVE Apple's problem?
The easier part is that we don't have to build QEMU and to rebuild it and everything. It's just Apple doing the builds and the updates. I cannot make any guarantees that if there's a CVE in the virtualization framework code, that Apple is going to fix it quickly. If there's a bug even in that code, I cannot make any promises that it's going to get fixed. At least we don't have to ship ourselves the CVEs and to be available to make the builds.
Okay, Christophe, thank you so much for your presentation. We need to go to the next session. We will share the recording and your slides on our webpage if Christophe shared it with us. We will put it there. And I hope you join us for the next session, which is about container EMA using BF by Avery Blanchard and Lily Sterman. So hope to see you there. Thank you.
Thank you, everyone. Bye.